Okay, the purpose of this tutorial is to give a brief overview of the capabilities of HEC-RAS, focusing on primarily how we'll use it for the course. It has many capabilities that are more advanced than what we can cover, but if we go over the basics, it's easy to build from there. Before we get started looking at this is the actual HEC-RAS window I've got open here. We can go to the web page. I wanted to bring a couple of things to your attention. The first is there's some nice demos. If you click, again, the main page here, you go down to the demo, and there are some animations of these are all more advanced than what we'll do in the class, but they'll give you a good idea of what HEC-RAS's capabilities are. A lot of these feature that a new feature for version 5.0, which is a two-dimensional model, will only be running in 1D. But many of these are, and they're also unsteady, and we've only dealt with steady flows, and that will be the same with HEC-RAS. We'll only be doing steady flows. The other thing I wanted to bring to your attention is under the menu you see documentation. You'll want to go there, and I recommend from this page downloading the user's manual, the application guide, and the hydraulic reference manual. The user's manual gives an overview of HEC-RAS, and I'll talk a little bit more about that at the end. The application guide provides specific examples, and this is the example data that you may have installed. Things like how to model flow under bridges, flow through culverts, sediment transport analyses, things like that. This provides basically tutorials on how to implement those advanced features. There's also the hydraulic reference manual. This provides a reference for all the equations and explains basically how HEC-RAS solves these different problems. And we'll go through much of that in class. Okay, so be aware of that. And I recommend that you download them here. I'm having a little bit of trouble running them directly from HEC-RAS. So if we go to the window, you may be able to do this, but I'm having trouble with this. You can open the help window and and here are the different manuals. Again, user's manual, hydraulic reference, and applications guide. I'm not able to open them from here, so I've put them in a separate folder. There's also, if you chose not to install the sample projects when you installed HEC-RAS, or I think when you open it the first time it gives you this option, you can always install them from right here. And then there's some other things as a web page, how to customize the menu. There's a nice USGS reference for selecting the Mannings. This is actually based on the Barnes report that we saw in class a few weeks ago. Okay, so that's some background reading. And actually, before we get into it, what I would recommend as well is if you open the user's manual here, note that it's quite long. It's 960 pages, so I don't expect you to read cover to cover, maybe half or so of it. But before, I guess initially I would recommend reading the introduction chapter. It's only 7 pages, and it provides some good features. Basically, this general philosophy of modeling system, overview of program capabilities, overview of documentation, and this manual. This will help kind of get you oriented. So I recommend that you go ahead and read that after this video is over. You can download it and read it. Okay, so what HEC-RAS, again, the RAS stands for River Analysis System, and it's basically an open channel flow modeling program. And like many similar programs, we're going to work our way through the menus. HEC-RAS works with projects, so you'll always start a new project and save all of the relevant data within that project. And there's always, for each of the drawdown menus, there's a nice shortcut key. So here's the open an existing project, and then this is obviously the save. The edit, this is where you basically set your model up. And like pretty much every problem we've solved in class, one of the first things you want to know is what is your channel geometry. So is it a rectangular channel? Is it a natural channel, trapezoidal? What's the slope? Things like that. You will edit the geometry data to specify this. This is generally the first step of this type of problem. The next step is to specify the flow data. So what flow is passing through that channel? That's this next group. And again, we're going to do steady flow. There's also the possibility for unsteady flow. This quasi-unsteady is really for a sediment analysis, which is more advanced. We won't be covering that. And then there's also the opportunity to input sediment data and water quality data. Again, these are advanced topics that we won't deal with. Okay, and if you don't like the drop-down menus, I like to use the buttons here. This is your geometric data, like you see the little stream network here, and then here's your steady flow. You've got your Q, and notice it's relatively constant water surface. You can contrast that for steady flows with the unsteady flow Q. Notice Q is a function of time, and you got this little hydrograph. Okay, and then sediment here, water quality here. So those are your editors for setting up your problem. Once you have that set up, you go to run, and you basically select your analysis. We'll be doing steady flow analysis, but there's all these other options that you could read about in the user's manual if you're interested to learn more. But we'll focus on steady flows. Again, if you don't like the drop-down menu, which for this one I don't because I like the running man. So he's running on flat ground. He's performing a steady flow simulation. Contrast that with running up the hydrograph. This is an unsteady flow running through the dirt, sediment transport, and I'm not sure. This is a temperature gradient, so this is, I guess, your water quality simulation. Nothing clever to say there. And then this is a nice option, hydraulic design computations. If you're doing some design, this has HEC-RAS has really got some nice options here. But again, this is advanced. We won't be dealing with that. Okay, once you have your simulation run, you can view your results. And this is really, we'll go through this in more detail when we have some results. And again, similar to the drop-down menu, basically all of these keys over here are dealing with visualizing your results. And those can be visualized in the form of graphics as well as tables. So you have a lot of options there. Okay, and then that leads us nicely to the options drop-down. This one, we won't really use this that much. The main thing is to set the units for your project. So you can work in either SI or US customary units. It will default to US customary unless you tell it otherwise. I usually just change it manually so I know what system I'm in. And then GIS tools we won't use, but this is extremely helpful if you're working in natural rivers to use GIS data. Okay, we already talked about the help window. So that gives us a quick overview of the layout of HEC-RAS, and we'll pick up next time with actually running some simulations.